Very good morning, class. I hope you all went through the video which I had sent yesterday. We started with exercise 7.1 of the lesson assignment and sequencing. The method which we started is called as Hungarian method. It helps us to assign jobs to a particular person as well as derive an optimum solution. So class, as I told you, in your syllabus, there are two types of topics which are covered. One is minimization and the other is maximization. We are currently focusing on the minimization problems. Yesterday, we saw sums related to balanced minimization problems that included rows and columns which were equal. We also saw problems based on unbalanced and minimization problems, which showed us when the rows and columns are not equal, how we add a dummy and make it a balanced problem. Now today class will be focusing on the sums based on restricted assignment problems. Restricted means even if we are given 4 machines, it is not possible that all the 4 are in working condition. Still, we have 4 employees to assign them on the job. So let us see examples of restricted assignment problems. So here we go, example of category 1, restricted and balanced problems are also there, as well as there are restricted and unbalanced minimization problems. Now here is an example, pay attention. 3 new machines M1, M2 and M3 are to be installed in a machine shop. There are 4 vacant places A, B, C and D. Due to limited space, machine M2 cannot be placed at B. The cost matrix in 100 rupees is as follows. You have to determine the optimum assignment schedule. So class, do you all remember yesterday I told you whenever you see any word problem, always check 2 basic conditions. Number 1, the rows and columns should be equal. So are the rows and columns given in this particular problem? Will class? No. So that means this is an example of unbalanced minimization problem. Secondly, can you see a blank space over here? As they mentioned that due to limited space, machine M2 cannot be placed at B. So class, whenever you see any vacant place such as a dash or a blank space in a particular problem, you have to assign a specific symbol to it. So either you can write capital M or you can put the sign of infinity as follows. So here is the step number 1. You have to add a dummy row M4 in order to make it a balanced problem. Also, as you all can see, I have filled the blank space with the symbol infinity. So if you all keep the blank space as blank, you won't get any marks. You have to either replace it by capital letter M or with an infinity sign as shown here. So after dummy row, our problem has become a balanced problem. So we can go to the next step, that is row minimization. So I hope you all remember what is row minimization. You have to pick up the minimum number from each row and subtract it from the respective elements of the row. In case of infinity, nothing will happen to it. It will remain as it is. So converting in row minimization and after subtraction, this is what is the matrix you will obtain. After row minimization, the next step of Hungarian method is to convert it in column minimization. So from each column, you will highlight the minimum number as you can see. In every column, the minimum numbers are 0. So the matrix obtained after subtraction will look somewhat like this. So before moving forward and drawing the lines, let us check whether in each row and in each column, I have at least 1 0. So the condition is satisfied. Now we'll be drawing the required lines. You all remember class? How did we draw the line? Correct. You have to take the rows which has got maximum number of zeros. So in this case, I have got M4 which is having 4 particular zeros. So the first line will be drawn on M4. After the rows are over, the next thing we have to move on to are the columns. So as you all can see in column A, B and C, each column is having 1 0. That means there is a tie. So we will draw the 3 lines simultaneously like this. What's your observation, class? As you all can see, we have got 4 lines and there are 4 rows and 4 columns. So as the number of lines is equal to the number of rows and columns, we allocate the jobs as below. So do you all remember, class? What was the technique I taught you all for allocation? For allocation, you should always start with the rows and having 1 0. So in the first row, I've got a single 0, so I'll put that in a box. When you're assigning the jobs row-wise, you have to see that in that particular column, if there is any other 0, it should be cancelled. Moving on to the second row. So in the second row, as we saw, there is again 1 0. So I'll assign that particular job in a box. In that specific column, I can see another 0, which I will cancel. In the third row again, I can see a single 0. So I will put that in a box. And the simultaneous, the consecutive 0 below it will be cancelled. In the remaining row, 3 zeros are cancelled, only 1 remains. And in that column, there is no other 0 which has to be cancelled. So as you all can see, class, each particular machine is assigned to each particular person without repeating the person or the machine. So our final table will look like this. M1 is given B, M2 is given C, M3 is given A, and M4 is given D. So we have to find the minimum cost. This was our original table consisting of a dummy. This was the table we got as the final answer. Now you have to compare your question with the boxes you have assigned. So in this box, I can see the cost as 10 rupees. In this box, I can see the cost as 13 rupees. In this box, I can see the cost as 5 rupees. And here, the assignment is 0. So the total minimum cost will be 10 plus 13 plus 5 is equal to 28 rupees in hundreds. So in this way, the restricted unbalanced minimization problems can be solved. Moving forward with the next example, one more sum I have solved for you all in order to be clear with what you saw. Now this example is from your exercise 7.1. This is sum number 4. So giving you all 2 minutes to read the question. So class, as you all saw, the topic is of cost. Cost represents minimization. Also, you have to check whether the rows or columns are equal or not. Again, in this case, we are missing out with the one single row, that is M5. Also, the objective function is of minimization. So what should be your first step, class? Adding a dummy row, that is M5, consisting of all the elements which are 0. Also, as you all see, in the blank spaces, I have put the symbol infinity. So we can move on to the next step, converting into row minimization. Picking up all the minimum elements and subtracting from their respective elements in the rows, you get a matrix like this. Moving on to the next step, that is converting in column minimization. So from each column, I've picked up the minimum number and I've subtracted. The matrix is the same as in the column, each minimum number is a 0. Now before we move forward, check whether in each row and each column, you have at least 1 0. We are moving on to the next step, that is drawing the required lines. Now to draw the line, class, tell me which row will be drawn first or cancelled first. Is it M2? No. Will it be M4? No. Yes, correct. It will be M5. So once we are done with the row, the second option is column. So tell me in which column will you draw the lines first? So as you all can see, in column A, there's 1, 0. In column B, there is again 1, 0. C does not have any zeros left. D has got 1, 0. But in column E, you can find 2 zeros. So class, the line which we'll draw now will be on column E. Again, the columns are finished. Again, we'll move on to the rows. So you have to go alternate. Row, column, rows, column. Now in row M1, there's a 0. In row M2, there is a 0. In row M4, there's a 0. So all the 3 rows are having a single 0. That means there's a tie. So we'll be drawing lines on M1, M2, and M4. Now what's your observation, class? The lines which we drew are fine. Compare it with the rows and columns. What do you observe? As the number of lines is equal to the number of rows and columns, we allocate the jobs as below. So class, can you tell me where should the first box will come? Correct. The first box will come in the first row as it has the 1 0. What about the 0 in M5? That 0 will be cancelled. Now coming to second row. Class, you see there are 2 zeros in that particular row. So we will not assign any job and leave it for some time as it is. Moving forward to row number 3. How many zeros can you see? Again 1. So I will put that 0 in a box. All the zeros in that particular column will be cancelled like this. I hope the logic is getting clear. In M4, again you see a single 0. So I will assign the job to that particular row. And in that particular column, whatever 0 you see, you have to cancel. Now again in row M5, you see there are 2 zeros. So for the time being, we'll leave it and not assign any jobs. As you all saw, class, in row-wise assignment, I assigned 3 particular jobs. Now all the rows are finished by seeing them once. Now we will see column-wise how many possibilities do we get. So in the first column, the jobs are already assigned. So there's no need to allocate one more job. In the second column, class, you'll see again there are 2 zeros. So leave it for the time being. We'll move on it further. Coming to the third column, you can see a single 0. So whenever you see a single 0, assign it in that particular box. When you're assigning the jobs column-wise, all the zeros in that particular row should be cancelled. So I will cancel this particular 0. So column-wise, as you all can see, we have already assigned the jobs. Again, we'll go row-wise. The first row is already having a job. Now in the second row, we can see there's only 1 0 left. So we'll assign the job to that particular row and see to it that in that particular column, the 0 should be cancelled. So in this way, class, this is the way of assigning jobs when you have more than 1 zeros. So whenever you have choice, leave it for the time being and come to it later on. So this will be your final table. M1 is given A, M2 is given B, M3 given E, M4 D, and M5 C. This was your original question. And this was the answer that you derived. So here we had to find out again the minimum cost. The minimum cost on comparing, you get rupees 12. As the first box over here has a 4. The second box over here also has a 4. The third box over here has a 2. The fourth one also shows 2. And the last one shows a 0. So on adding, you get the answer to be 12. So I hope class the restricted minimization problems are clear. Now, I am giving you one sum to practice. This is your sum number 6 from exercise 7.1. I want you all to practice and see for yourselves. Are you all clear with the topic which I have taught you all today? So till then, keep studying, keep practicing. See you tomorrow for the next lecture. Thank you so much for listening to me.